Okay, so part 2 of this lecture is going to be on growth hormone. So growth hormone itself, kind of like testosterone, it starts in the hypothalamus. This is a little bit easier to remember because the hypothalamus releases what's called growth hormone releasing hormone. Growth hormone releasing hormone then binds to the anterior pituitary gland, which releases growth hormone itself. So this is how growth hormone is reported to work on muscle. Growth hormone goes to the liver. It stimulates the liver to release IGF-1. IGF-1 goes to the muscle, and the muscle grows, or quote, hypertrophies. So we know that IGF-1 increases protein synthesis and activates satellite cells, which we'll discuss later. So the thought is that it's indirect. It's indirect. And you remember testosterone had exogenous evidence. So what that means is that when you give testosterone, it increases muscle size. But unlike testosterone, exogenous evidence for growth hormone does not support this theory. So, basically what you're looking at here is C, or the top right graph. You see myofibrillar protein synthesis. That's when we think about muscle size. And below that, we see collagen protein synthesis. That would be a protein synthesis in the surrounding fascia, all the connective tissue. What you see is that the myofibrils are not increasing protein synthesis when you give the placebo versus the growth hormone. However, if you look at collagen from rest to exercise versus rest to exercise with the growth hormone does increase collagen protein synthesis. So what this basically means is that growth hormone may not be super anabolic to muscle tissue, but it seems to be anabolic to collagen. That's important because when we train, we want our connective tissue, our tendons, our ligaments, our fascia to adapt along with muscle. You can't just have the muscle to adapt without the connective tissue. Because that's important as well. Now, I also want to emphasize that there are numerous forms of growth hormone. And we're studying in here one isoform of growth hormone, the 191 amino acid isoform. There are numerous isoforms, and 99% of our research is on the 191 amino acid isoform. So we don't know what those other isoforms are doing, but based on this, we don't have the supporting evidence. So we think it's more modulating or controlling the connective tissue response, which is a good thing. So we want to optimize growth hormone along with testosterone so all of those tissues adapt coincidentally. So basically, we're seeing here is the effective intensity. So someone's training 8 reps at 60, 70, and 85% of their 1RM. And what you see is that growth hormone doesn't move on 60%. It goes up to 70, and then it goes up even more, 85%. So we see this dose response. So the question becomes, well, if I raise it from 85% 1RM to 100% 1RM, what will happen? If you go down here, basically you have A and B, and it's Hakkinen again. A is 100% 1RM, and B is closer to 75% 1RM. You see 200-fold mean increase in growth hormone at the 75%, whereas the 100% you don't see nearly any. And again, these are paralleled by blood lactate changes. So again, metabolic stress seems to drive the growth hormone response. Why is this the case? Well, essentially what happens is that, remember that the hypothalamus releases growth hormone releasing hormone. That binds to the anterior pituitary gland, releasing growth hormone. And that happens ideally at a lower pH. So when you train in a glycolytic range, 8 to 12 reps, with those repetitions, then what's going to end up happening is you'll have more of an acidic environment, facilitating the binding of growth hormone releasing hormone to the anterior pituitary gland. As far as rest period lengths are concerned, this is a study by the famous William Kramer. And William Kramer had people do five repetitions with 3 minutes rest, 10 repetitions with 3 minutes rest, 5 repetitions with 1 minute rest, 10 by 1, 5 by 1, and 10 by 3. Now, what do you notice caused the greatest growth hormone response? It's the 10 repetitions with 1 minute rest. So it's not just the intensity, it's the rest period length. Now, how many times do you go to the gym? Say, talk about Monday. What's Monday? For guys, it's like International Bench Press Day, right? So they go in the gym, and they do a set of bench, and then they talk to your friend. Oh, like, bro, you should see how messed up I got on the weekend. And they're talking back and forth, and 10 minutes has gone by. And does that matter? Yeah, it does. It seems to matter a lot, because why would rest period length matter? Well, if you're building up hydrogen ions, if you're increasing the acidity in the muscle and you rest 5 minutes, what's going to happen? You're going to clear that out. You'll buffer that, and you're not going to get the effect. So short rest period lengths, or what we call metabolic training, higher reps, shorter rest, seems to augment the metabolic stress. And the metabolic stress seems to augment the anabolic environment. As far as volume, the 24 sets versus 8 sets, 24 sets, they ended up doing 8 exercises, 3 sets apiece. 8 sets, they did 8 exercises, 1 set apiece. We see the growth hormone response is greater for higher volume versus lower volume workouts. Now, so basically growth hormone, the same variables that optimize testosterone optimize growth hormone, right? So, let's talk about manipulating growth factors. Here we have, let's talk about muscle action. What are the different types of actions that you can have? You have concentric or shortening actions, eccentric or lengthening contractions, and isometric or no movement contractions. So basically what happens is that, and then we have fast versus slow contractions. So of contraction types, what do you think causes the greatest growth? Concentric, eccentric, or isometric? Well, here you have baseline, or if you look over the right, it's the easiest to understand. Lengthening contractions, which are eccentric, versus shortening contractions, which are concentric. You see protein synthesis is greater in shortening contractions. And we also see the graphs to the left that things like IGF-1 is greater in eccentric contractions versus concentric. So basically what we're saying is that eccentric contractions do seem to stimulate the most growth, and likely it's because they're stimulating damage and growth factors. Now, that doesn't mean that you're going to ignore the concentric phase, because most movements in sport couple the full movement, right? But it does seem to indicate that, you can't just drop the weight on the eccentric, you got to have somewhat control. Okay, so what about slow contractions? Slow contractions. Well, if we look here, we look at fast versus slow contractions. A lot of people tell you to slow the weight down, slow the weight down. Well, they've done studies. This is muscle fiber growth. You look at before is the open bars and after is the black bars. When you lifted the weight fast, you got more increase in muscle fiber size. When you lifted it slow, you got less increase in muscle fiber size. Basically what happens is that faster contractions, what they do is you don't have enough time to build up cross bridges between actin and myosin. That means that the same weight is borne by less cross bridges. That means you have more stress per cross bridge. More stress per cross bridge means greater adaptation per cross bridge. So basically faster contractions result in more damage, more release of growth factors, and greater growth. So going slow, or selecting a lighter weight so you can lift in a slow cadence is, 1, it's not sport specific, and 2, it's not going to make you stronger, and 3, it's not going to make you bigger. So basically, you want to lift what we call for sport specific with maximally intended velocity. Control the weight, use good form, but within that context, let the weight dictate the velocity. If you're lifting with 40% of your 1RM, yeah, you're going to lift fast. If you're lifting at 90% of your 1RM, the weight itself is going to slow you down. So in summary, if we summarize these last 2 lectures, testosterone is a regulator of neural function, strength, power, and ultimately hypertrophy. Acute changes do augment growth, and they also augment power. Chronic change in testosterone augment the overall adaptive process. And growth hormone may be more important for changing connective tissue growth, but this is still critical. So practical applications for hypertrophy of both muscle tissue as well as a simultaneous increase in connective tissue supporting structures, individuals should exercise choice. What would you select? Compound movements. Exercise order. Legs before small body parts, increase the size of small body parts, or compound before isolation. Intensity. Moderate intensity, right? 8 to 12 reps or 70 to 85% 1RM. Volume. Volume, where basically all I want you to know is that it's what? Multiple or single sets? Multiple, right? Rest. 30 to 60 seconds, right? No more than 90. Definitely no more than 2 minutes. For chronic changes, what's the key? The answer is training that is periodized or varied over time. If program is not varied, testosterone will go back to baseline. For muscle growth, what's the optimal contraction type and velocity? The answer is eccentric and maximal intended velocity. Oh, that's my cat Diego. He fell asleep while I was doing this lecture. So if you have any questions, I'll take those in class or in my office hours. Thank you.